today we're not really learning anything new technique-wise. We're just taking what we've already learned and we're problem solving with it. So, question 1. First, let's talk about strategies for problem solving. What you kind of want to do is pick out key pieces of information. So, key part of this question is going to be that you have a rectangular garden. So that you can actually draw out what the garden would look like. And you have that one side length is 8 minus 3a. You'll get used to it. And the width is a plus 8. And it contains a square flower bed with a side length of 2a plus 5. So you're also going to want to highlight that it's square. It's basically about picking out keywords and then actually drawing out the problem. That's why question 3a is draw the diagram. So you have a rectangular garden. One side length is 8 minus 3a. And then the other width is 2a plus 5. Yeah, no, it's a plus 8. I read this square. Correct? Then inside of that rectangular garden, you have a square flower bed with a single length of 2a plus 5. So inside this, you have a square garden bed. You don't know where it is, so I'm just going to put it here. And the side length of that is 2a plus 5. If it's a square, that side length is the same side length for all 4 sides. That's why we highlighted that it was a square. That should be your picture of your garden bed. Pretty simple. It's an important step to just understanding the question. Because if you mess up the drawing, then you're going to mess up the rest of the question. So write and simplify an expression for the area of grass in the garden. Where is the grass in the garden, Ella? Yeah, Aiden? Yeah, on the sides. Which is what I was going to say. Sorry, I just saw Aiden behind your head. His hand up user. So this area
I swear I don't know why.
Is grass.
Oh boy! That's good. Action.
Like actually, that's all. Just. So you need to write and simplify an expression for the area of the garden. So you're gonna have to figure out the missing pieces of that garden. You can take this square and you can push it all the way to one side or all the way to the other. It doesn't matter because we don't actually know where that square is, correct? So if you imagine this red square was right off to the side, it'd make it way easier to calculate because then you only have to calculate one missing area, right? Does that make sense? Ella?
If it's like in the middle, especially like both edges, it's like be a plus a on all the sides.
Yeah. So if it was exactly in the middle and you had an even side here, even side here, then you would know that's 8 plus 8, right?
No, but like this is all the sides the same, but the same size instead of like the width you're at, it would be a plus a plus 5.
Oh, I see what you're saying. So if this was actually touching both sides. Yeah, that's a good point. I wonder if it works out to be the same. It should work out to be the same then, we'll find out. I've never even thought of it that way, Ella, but let's see if it works out. Really?
Yeah, it was.
She means that because you get the same like width.
Then you know that is the same as that, right?
Yeah.
Yeah.
make it smaller, because it's the same width, or else it'll be 8 plus 8.
Yeah. So then you would change it to be like this. Like it wouldn't be touching the sides, right? Yeah, that's wrong. You would have this inside like that. That's what you're going for? Yeah.
Is that what it's supposed to be?
Yeah.
What's the
The diagram looking this way is much more accurate of a drawing.
Okay.
My drawing was inaccurate. So leave that at 8. It doesn't make a difference if you wrote it out and if you're able to visualize it as being different. But if you're a pictorial person like Ella is, that makes more sense, right? To you? Yeah. We're on the same page. I'm saying that that's the right way to do it. That's a more accurate drawing. Both ways are right. It makes no difference because yeah, as long as you use the proper side lengths, that's all that matters. So that side length is yeah. Because all you're going to do when you solve the question is you're going to calculate the area of the entire rectangle and subtract out the area of the square. So it doesn't matter what your drawing looks like as long as the side lengths are labeled accurately. So find the side length or the area of just the rectangle. There you go, 8. Yeah. That's going to be the area of what? Matthew. What's that going to be the area of? I've said it a whole bunch of times. What is it, Josh? This? Forrest, what's the area of? The whole thing. It's this entire length times this entire length. So that's going to be the area of the entire rectangle. Thank you, Boris.
And then do you find the area to minus it?
Yeah, exactly. How do you calculate that? Foil it. So what do you get when you foil it? Give it a shot. The inside would be minus 3a squared. And the last would be minus 24a. Okay. Okay, so we have the area of the entire rectangle solved. How do you get the area of the square now? Ella, you had it right. You multiply the two sides, right? So you go 2a plus 5 times 2a plus 5. You do FOIL, that's going to give you 4a squared. The inside and the outside is going to give you 10a. Nope, 28. 10a plus 10a. And the outside is going to give you, or the last is going to give you plus 25. In the black, you have the area of the rectangle. In the red, you have the area of the square. Yes?
Well, I see foil, like, that's going to be squaring it, so.
That is squaring it, right? Same thing. You could just write that as square, but when you do binomial by binomial square, you have to write it out like that, and then you have to FOIL it.
Yeah.
You can't just apply the squared in.
Isn't it all four sides that you have to use?
That's if you're doing perimeter, right? So to calculate area, you do length times width. And in a square, the area, the length and the width are the same thing. Right. Okay. Take the top one. Subtract the bottom one. How many a squareds are you going to have? So you're going negative 3a squared. We're going to collect that term and that term and give you minus 16a. We're going to use that. It's plus 64. We're going to subtract all of that. So I brought like terms together, then I wrote it as the area of the rectangle minus the area of the square. I'm going to have to apply that negative in. Yes, Matthew?
We're gonna get this much right on every question.
Probably more. These are just binomials, right? So there's going to be a lot of steps to every question. You're just going to have patience and work through it. When you apply that negative in, you're going to have 3. These things are all staying the same. The negative inwards changes it to a positive. And you're going minus 4a squared minus 20a minus 25. We've seen this before, right? Now that it's a positive in front of the brackets, all we have to do is gather our like terms. Go ahead. What do you have for a squared? Negative 7. We cross that. That's negative 7a squared. What do you have for a's? Minus 36. You have that? You have that. Minus 36a. And what do you have for a constant? 39. 64 minus 25. Positive 39. What does this answer represent? The area of the grass. Yeah, the area of the grass. So it's the remaining area of our picture, the green area. Any questions? When you guys write tests, you're going to have some simple ones at the beginning where you just have to multiply one number in. Then you're going to have a couple questions where you have to FOIL. And then you're going to get word problems like this. And these are going to be worth the most marks. So make sure if you have questions, you ask. Part C. Determine the area of grass if A is equal to negative 1.5. How do we solve that? Josh. Yeah. Not times by, but replace with. So anywhere in this answer where you see an A, you're going to replace it with negative 1.5. So to answer C, part C. Do it on the You have negative 7, and you use brackets to sub in your numbers like that. So to sub in your negative 1.5, you put it in brackets. And that matters because when you're squaring negatives, you need to make sure it's in a bracket. Otherwise, you're going to get the wrong answer. Minus 36, negative 1.5, plus 59. You need to get your calculators out to solve that one. Go ahead and try it. See what we get for answers. Just wait. Pull out your calculator. Give it a try. See if you can get this in your calculator right. All right, Josh, what's the suggested answer?
Negative 15.75.
No, I want a final answer. Do it all. Put it all. So you figured out each one. Put it all together. I want suggested final answers. Tell me what's your suggested final answer? 95. Like what? Okay, well, let's see. Others try it. What did you get? 131.25. Hello, what did you get? 77.25.
Wow, we're getting a lot.
Oh, we're all getting
This is why you all need to get your calculators out and try it. We've already got 3 different answers from the first 3 people who tried it. What did you get, Josh?
72.25.
72.25.
Everybody's getting the 0.25 at least.
Yeah, okay.
There's the first. Of course, what did you get? 889.
Oh, whoa.
That don't seem right.
38.25.
203.25.
Okay, you all need to get your calculators out and try. Hannah, what did you get? 77? Hey, we got some people doubling up. That's a good sign. Okay, in your calculator, the best way to do it. Yes, 77? Okay, the best way to do these types of problems in your calculator is to break it down and do one thing at a time. If you try to write in every step at once, you're probably going to get a mistake because your calculator is probably not going to know what you meant. First thing you should do is in brackets go negative 1.5 to the power of 2. And that should give you positive 2.25. Multiply that by negative 7. That makes your first term negative 15.75. Everybody got that? Your second term. Second term. Go negative 1.5 times 36. That'll give you negative 54, correct? And if you subtract the negative, what to do? It makes it positive, so positive 54. And then your plus 39 shouldn't change. Add those things together, and you should get 77.25. Any questions about how we did those computations? Okay, that's good. Everyone should get 77.25 now. Anybody not getting it in their calculator? Alright. Did you get it? We'll take a look at it after. So what's your final answer? 77.25. What's the area of the grass? What's the unit? Meters what? Squared. You rate area as squared. 77.25 meters squared. One more. All of that to figure out how much grass there was. Remember when we talked about like math that we do a lot of math that we don't actually get to apply much of? This is actually stuff that people use every day. So like architects and stuff like that.
To get started off,
Not always, right? Because if they're building a house hypothetically on a chunk of land, they might know the entire width of the land, but they don't know how far in they're allowed to come yet. So they would go, well, I know I have 100 feet this way, but I have to come inwards a certain number. So they leave it as X. And they calculate it hypothetically to start. So that's kind of cool. The hypotenuse of a right triangle. Key information. Right triangle. So, a right triangle has what? 90 degrees. Where's the hypotenuse? Dawson. The hypotenuse is, if you look at the right angle, it's the opposite from it. So that's the hypotenuse. It's it's the longest side. It's the side that's across from the 90 degree. And ours is 5x plus 5. And the lengths of the two other sides, you can choose which side's which. This one's going to be 3x minus 5. And this side's going to be 4x minus 8. You can choose which one's which. That's my doing. Form an equation to solve for x. Matthew.
Wouldn't you put them all in brackets in the power of 2?
Yeah, no, you're on the right track. Because what are you using? A squared plus b squared equals c squared, which is Pythagorean theorem. That's how you're going to create an equation. That's the only equation that we know with triangles. Right? So go ahead. A squared plus b squared equals c squared. So 4x minus 8. Wait, first I guess we have to cover it. It is what is a squared, what is c squared, and what is b squared. Your a and your b don't matter as much as your c. Your c has to be your hypotenuse. Has to be. Absolutely has to be. Your a and your b can be either side.
It's 4x plus 8.
4x plus 8, yeah. That's our headed here, y'all. That's your a squared plus your b squared is 3x minus 5. And that's equal to your c squared, which is 5x. We have to solve for x. That means you're going to have to expand that, and then collect a lot of like terms and do a lot of algebra. We know how to do all those things. It's a lot of steps, right, Jerry? But they're all steps we know how to do, because all it's going to involve is what? Foiling, binomials and binomials. So go ahead. 4x plus 8 times 4x plus 8. That should be 16x squared. And then you're going to get your outsides will give you 32x. Your insides will give you another 32x. And your last will give you 64. Okay, I heard we're confused. So what we're going to do a quick recap. We took our information. We drew out our triangle. We knew our hypotenuse was this side. These two other sides we chose. We chose this one to be 4x plus 8. We chose this one to be 3x minus 5 on the bottom. Matthew helped us out. He said an equation we know is a squared plus b squared is equal to c squared. I'm going to draw it up here. That's Pythagorean theorem. Each letter represents one side. This is C. This is our A. And this is our B. The side that's most important to understand is your hypotenuse has to be your C. Now all we're doing is we're expanding. That squared is equal to that. You're going to do that 3 times. And then you're going to combine all your terms. Does that make more sense? Yeah? Okay, expand your next one. 3x minus 5 times 3x minus 5. That's going to give you 9x squared. Your outside's going to give you negative 15x. Your inside's going to give you the same thing. And your last term is going to be positive 25. And then do it for 5x plus 5. Tell me what you get when you expand that one. Somebody try it. Yep, 25x squared is the first term.
Plus 34x is
5x squared plus 34x? Where'd you get 34x?
Oh wait, no, that's out.
25x plus 25x plus 25x plus 25. Does everybody know where those numbers came from? First, outside, inside, last.
So we'll just fold it.
We just foiled each one, yeah. And now you have a ton of numbers, right? We know we have to add this, and we have to add that. So go ahead and add it. What do we have for x squared if we add those two things together? 16 plus 9 is what here? 25x squared. That came from here plus here. How many x's are we going to have? Plus 34x. That came from 32 plus 32 minus 15 minus 15. You did your calculator, right, remember? So 32 plus 32 minus 15 will give you 34 x's left over. And then what are your constant terms going to give you? Plus what?
Or 80.
Yeah. That gives you this side. That gives you that side of the original equation, right? It's a lot of math to keep track of. So organization is going to be key. Yes, Matthew?
Shouldn't we just got from there equal up?
Right, we got to do this one now, right? So that's equals to this stuff, which we have to simplify. How many x squares are we going to have, Johnny? Yeah, how many x squares are we going to have, Matt? This one. We're going to have 25x squared plus, there's no other x squares. So it's just 25x squared. How many x's are we going to have? How many, Chloe? 50. So we did 50x by going 25 plus 25. Plus 50x. And your constant term is still just 25. It's a lot of math, I know. Now you have to do like terms, bring them together. So you have to move things from this side to that side, or vice versa. So we have to move all of our stuff to one side of the equation. You have to move all the green to the left side of the equation, or all the blue to the right side. I'm going to move all the blue to the right side. The reason I'm doing that is because I recognize that this right here is going to cancel out with this right here. So my x squareds are going to go away when I subtract it to the other side. This x is smaller than this x, so I'm choosing to leave the bigger x alone and move the smaller one over. That way I'll only have positive x's. Makes it a little bit easier to deal with later. You can go either way and it's fine, you'll get the right answer. But if you follow what I just said there, it'll make your life a little bit easier. To move this to the other side, we have to subtract it. To move this to the other side, we have to subtract it. To move this, we have to subtract it. What would you be left with on the left side if you subtracted everything away? 0. On the left side, we have 0. And it's equal to the green side is still all going to be here. The blue side is now moved all over to the other side, except they're all negatives now, because we subtracted them all. So it's going to become minus 25x squared minus 34x. It was 34, right? Yeah, and minus 89.
This
needs to be there.
Does what? If you could automatically do that, like if you could have just figured that out in your head, then that's okay. My guess is that writing it out will help you from making any kind of silly errors, right? Like things that. Okay, Aaron, what's your question? I don't know. Let's check it. Okay. So then you have 0 is equal to, and you combine it, your x squares, that's going to cancel with that to give you nothing. 50 minus 34 is going to give you 16x left. Pardon? Yep. This is still part A continued. 25 minus 89 gives you what? Negative. Ooh, we got some different answers. Negative 64. Yeah. We're so close. This will do the trick. Yeah, because we can solve for x now, right? Because we have x all alone. There's only one of them. There's 16 of them, but there's no x squared, so nothing crazy. So how do you actually solve for x? You have to move the 64 to the other side and then divide it by 16. So watch that we're going to move that 64 to where the 0 is. So it's going to become 64 is equal to 16x. But we don't want to solve for 16 x's. We want to just solve for 1x. So you divide both sides by 16. So 64 divided by 16 is equal to x. This is all stuff, this is all algebra. And they expect you to know this stuff as review from grade 9. Which is a lot, yeah. When it came over to the other side, we had to add it to this side, which means we had to add it to that side. The only way to cancel it on this side was to go plus 64, so it canceled out, and then the plus 64 popped up on the other side. X equals. All of that is equal to 4. Usually if you pop out and you get an answer that's like x is equal to some ridiculously large number, it means you probably did something wrong. If it comes out to something simple like x equals 4, it probably means you did something. Yeah, it's not a guaranteed thing, but it's usually like this. Yeah, Matthew. Yes, sir. Okay, there's like 2 seconds left. How do you determine each length of the triangle now? You just sub in 4. So you're going to put 4 into this side, 4 into that side, and 4 into that side, and it'll give you the 3 side lengths. Does anybody have questions on how you solve for a side length? Would give you the side length A. Josh. Yeah. You guys don't have a test till next week. So, we'll do side A.
Not more of this.
To figure out side A, anywhere you see x, sub in a 4. So it'll become 4 times 4 plus 8. And that should be equal to, 4 times 4 is 16, plus 8 is what, Ella? 24. That's all my stuff. 24. Does that make sense, Aaron?
Yeah, how many points would that be worth on the test?
A lot. That's why understanding these is worth. You'd probably get 1 mark for drawing out the triangle. Probably get a 2nd mark for writing out the original equation. You'd probably get 2 more marks for this work. So probably a mark there for foiling, a mark there for combining, another mark there for being able to bring it back over, another mark there for subbing in your 4. So you're up to 1, 2, 3, 4, 5, 6. You'd probably be almost 8 marks. On your test, your marks are usually like 40. So this could easily be like a 5th year test. This would be like your written response type questions, which are always worth more. Any other questions to how we solve that?